Welcome back, Stats. This is what we're going to be doing today, just two-way frequency tables. This is something that we've already done in the past when we looked at conditional probability at 3.2 last week, but we're going to be reviewing a lot of it today and diving a little bit more deep into what two-way frequency tables are. So first, we're going to go to the bell work, then the homework quiz for 3.4, and then finally two-way frequency tables and just a couple of examples, and then we'll get to the closure. So these are the three homework questions that I chose to be putting on for bell work to review 3.4. And most of the time that these will be questions that you'll more than likely see on the homework quiz, so just keep that in mind. So first question, there are 33 members on a board of directors for a certain non-for-profit institution. If they must select a chairperson, vice president, second vice president, and then a secretary, how many different slates of candidates are possible? So there's 4 out of 33. So my N will be 33, and my R is 4. Now the real question is, okay, is this NPR or NCR? Now since it is rank, vice chair president, secretary, chairperson, so forth, it's gonna be permutations, NPR. Permutations is where order matters. Combination is where order does not matter, okay? So that means I'm going to do permutations. So 33, P4, okay? So let's go to decimals real quick. 33, P4. How do I do that? I do NPR and then 33, comma 4. So 982,080, okay? Pretty big number, but 982,000 and then 80, right? Yeah. So that's how many different ways you can arrange these different 33 people if you're taking 4 out of that 33. Okay, so very short to the point, very simple, but the hardest part is really just distinguishing between permutation and combination. Second step, second problem, decide if the situation calls for permutations or combinations, or even neither. Now, I'll give you a hint, it's never going to be neither, okay? But explain the reasoning, the number of ways 12 people can line up in a row for concert tickets. Now, this one's kind of misleading, okay, personally. It is very kind of misleading because it doesn't really matter who lines up in the row of concert tickets. However, getting into the concert, it does matter. And I believe Math Excel, for this case, Math Excel is going to say permutation. So this is a clear permutation, only because it does matter if you get into the concert, if you're in the row, and it matters if you're specifically going into the concert. So I know that's kind of maybe like a low ball for you guys, but it is definitely permutations. It is the order that you line up and actually go into the concert, that matters. Maybe not the way maybe not how you line up, but the way you line up and that you're lining up, it actually matters, okay? Very sleight of hand there, so I apologize, but that's why we're going through these questions, all right? And the next one is just 7C4 all over 12C4, okay? 7C4 all over 12C4. How do I do that? Well, first, let's go to Desmos. So I can do NCR, so 7C4 all over NCR, and then 12C4, I think it was, 12,4. Let's go back and double check. Yep. So that means I have 0.07 and then, yeah, let's just do 0707. So 0.0707. And that is my combination, 0.0707. Boom. Okay. So I hope that helps. I hope that makes sense for you guys. Those are the only questions I'm going to go through with you. So I'm going to race, get you guys started on the homework quiz. You have 20 minutes, 5 questions, and as soon as you're done, make sure you review your answers. Send any partial credits to me if necessary. But other than that, go ahead and start on your notes for the two-way frequency tables. And then you can start writing down the essential question. Why are two-way frequency tables important in collecting data, especially in conditional probability? And then how we're going to use two-way frequency tables to calculate probability. So let's get started without further ado. This is what a frequency table looks like. This isn't a two-way frequency table. This is just a normal, straight-up frequency table. So frequency tables allow us to organize our data and basically utilize it for experimentation, especially with probabilities. Okay, so let's just say, I tallied you guys up in class, and 3 of you liked English, 5 of you liked mathematics, 8 of you liked history, 9 of you liked science, 3 of you liked electives. Okay, and you had 28 total. Okay, let's just say that. Now, how many of you like English? Well, this is pretty straightforward. So 3 out of 28. Okay, and then we can reduce from there. I'm actually not going to give you decimals. I'm going to probably just stop it right there. I'm just going to leave it in simplified fraction terms. And I hope that's okay. So that's how many of you like, that's the probability of those who like English as their favorite subject. Now, what about math or science? Now, it says or, right? Which means we have to add. So math, you have 5, and then all over 28. And then plus, that's what or means, plus. So science, so we have 9 out of 28. 9 plus 5 is 14 out of 28. And this reduces down to 1/2. So that means 1/2 of these students like science and math. Okay, 1/2 of these students like science and math. Awesome. Elective or history. So elective is 3 out of 28, and then plus, because that's what or means, plus history, which is 8 out of 28. So this reduces down to 11 all over 28, and since you can't simplify that anymore, I'm just going to keep it at that. So that's basic frequency tables. I'm pretty sure we already did this, especially if we go back to 3.1 last week on Monday, the basics of probability. We did do this. This was just normal frequency tables. So that's for review. Now, what about what we call two-way frequency tables? Two-way frequency tables allow us to organize data into more than one category, not just one category, but more than one. Normally, 3 categories, 4 categories, doesn't matter. We can do whatever we want. And conditional probabilities then can be found using two-way frequency tables. And that's why conditional probabilities are so helpful, okay? And that's what we've learned in 3.2 last week, okay? So this is an example of right here, this is an example of a two-way frequency table that you'll see on Math Excel, okay? So use a two-way frequency table to find the probability. Now, the degree is not an associate, so the probability that the degree is not an associate, and that's what I'm going to do, that little tilde symbol is not, given that the recipient is female, okay? That's what it is. So what this formula tells us, if you remember from 3.2, is the probability of not associates and female, so the overlap, all over the probability of the condition, just female. So this is my formula, and then we can kind of piece it together on our table. So if you're not associates, that means you are bachelors, right? So the bachelors and female. So what's my overlap? This is the overlap, remember that. So this overlap is right here, okay? Bachelors and females, so I have 872. All over 872, all over those who are female. Now, the problem is we don't have a total here. So that means we need to actually total this up. So we take 872 plus 351, and we get 1,223. And so the total female, 1,223. Now, of course, this may be able to simplify that, so we're going to put in decimals, 872. So 872 divided by 1,223. And then see if we can simplify it here, and no, we cannot. Okay, we can't put a decimal here, so let's just do it since we're here. 0.71. Okay, let's round it off there. 0.71. So about 71% roughly, is not, the degree is not an associate's given that the recipient is female. So if the recipient is female, then, what's the probability that they don't have an associate's? That's what we just found. If the recipient is female, what is the probability that they don't have an associate's? Boom, that's what we found. Okay, now we kind of did this with 3.2. Like, this is a lot of review for 3.2 because we already kind of did that. We're going a little bit deeper in to kind of solidify the two-way frequency table math here. So let's actually get into a little bit more examples here. So let's just say this is our given chart. And just looking at the class, let's just say I have 3 freshmen, 5 sophomores, 12 juniors, 13 seniors, total class of 33 kids in my stats class, okay? Where I have 1 here, 1 male here, 2 females here, and so forth. Now, what I want to find is a multitude of different probabilities, okay? FM will stand for female, F will stand for freshman. So what it's saying is, what's the probability of finding freshman or female? Okay, so freshman is 3 out of 33, or, so plus, female. So female is 16 out of 33. Now, can you be a freshman or a female at the same time? Well, yes, you can. So that's when we have to subtract the overlap. We need to subtract the overlap, freshman and female, which is this 2 out of 33. There's 2 freshmen that are female, right? So I need to subtract that out. So total, I have 19 minus 2, which is 17 out of 33. So the probability of selecting a freshman or a female is 17 out of 33. Now, again, this is tricky because you have to subtract that overlap out. Again, this should be reviewed from 3.3, the addition rule. Now, juniors or freshmen. Now, since they are mutually exclusive events, since they aren't mutually exclusive events, we also have to subtract out. So I said freshman, I meant female. So juniors or female. Can you be a female and also a junior? Well, yeah, sure. You can be a female and also a junior, okay? Which means you have to subtract that out. So let's start with the juniors. What's the probability of getting a junior? Well, that's 12 out of 33. Females plus, we already did it, 16 out of 33. But I need to subtract out those who are juniors and females. So juniors and females is 6 out of 33. Out of those two together, you get 28, and then minus 6, so you get 22 out of 33. And I cannot simplify it anymore. Perfect. Now we're getting to conditional, senior, given that they're male. So I want to do the overlap all over the condition, which is male. So the overlap of seniors and males are, right here, 8. So 8, that's the overlap, all over the total of males. So what's the total of males? 17. Okay? So the conditional probabilities are a little bit more intuitive there, and that's what we like. Okay? Sophomores, given that they're male, so the overlap, sophomores and male, are 2. So we're going to put 2 all over the total males, okay, which is 17. And again, I can't simplify this out anymore. Okay, I hope that kind of solidifies some of our probability rules, the addition rule at least, and then the conditional rule. So let's erase, let's get to another table. We have 2 more after this, and let's start doing some more math. So still, we're going to keep with the same amount of females, same amount of males, same total, but now we're looking at their eye color. So what does that mean? Okay, if I'm given green, find the probability of green given female, so the condition is female. Can you have females with green eyes? Well, yeah, so we need to make sure that we have that overlap. Okay, so females with green eyes is 4, all over the total condition, which is females, so 16. And this, of course, reduces down to 1/4. Okay. Now it's and, so that means multiply. So blue and orange. Okay, or not orange. That is definitely another. Okay, this could definitely be orange if you wanted to, if you have those weird sort of contact lenses. But other, so blue or other. Sorry, blue and other. Blue and other. So blue is right here, total is 8. So I have 8 out of 33. And then times other. So other is 2 out of 33. So 8 times 2. 8 times 2 is 16. And then 33 times 33 is 1,089. And if we can simplify that, we could. So 16 all over 1,089. I don't actually think it does simplify. Let's go to decimals real quick. 16 divided by 1,089. See if it simplifies down at all. It does not. Okay. So that means this is my final answer. Perfect. Great. Now blue given, male given blue. Male given blue. Find the probability of male given blue. So males, overlap is blue, so that's 4. And then all over the condition, so total blues is 8. So that means the probability of finding a male given blue is 1/2. Now find the probability of female given green. So female given green, so that means it's 4 right here. That's the overlap all over the condition, which is total greens, which is 9. And that is my probability. So notice how these are very similar because they both involve green females, but they're a little bit different because the condition is different. Okay, perfect. Let's erase that. Go on to my last one. So now Apple versus Android. Okay, same amount of females, males, same amount of students. Find the probability that you have an apple given that they're male. So what's the overlap? It's 5 all over the total males, which is 17. Find the probability of Android given that they're female. So what's the overlap? Android female is 1 all over the condition, which is female, so it's 16. Okay? Find the probability that they're male given that they have an Android. So male given that they're Android is 12. So 12. And then the Android total is 13. And then the probability of just female. Now notice that this is not conditional. Okay? So just female is 16. All over the total is 13. Okay? Find the probability of just getting females here. So now it's just, I don't even care about the second categories of phones here. I just care about male and female. In this case, just female all over the total. Okay? So that's all I have for this lesson, guys. Really and honestly, that's really all I have because it should be a review or slightly a review. Okay, so please go through your homework on Math Excel. Just go through two-way frequency tables. If you have any questions, please be sure to email me and make sure you complete that homework quiz. This is C Squared Mathematics. Be sure to like and subscribe.